Seasonal hiring is very common in manufacturing. We will see how, by using nonlinear programming, we can optimize costs. In the given problem, a certain number of resources are required per quarter. The labor cost is 45,000 rupees for 3 months, and if they are not deployed on the line, an idling cost of 40,000 rupees, slightly less than the base pay, has to be given. If someone is let go, a one-time retrenchment payment of 20,000 rupees is given. Hiring new people is relatively more expensive. So, while having less people than required is not allowed, the expectation is that the team will have a strategy to minimize overall cost. The base wages is the labor cost corresponding to the minimum people required for the quarter. If final number of people deployed is higher, we end up paying idling charges. Depending on how the absolute numbers change between successive quarters, either a hiring charge or a cost of retrenchment is paid. The solver solves for the variable number of people to be deployed per quarter. There are two constraints: 1, that the actual number of people cannot be less than the minimum required, and that the variables will have integer values. We use the grg nonlinear function in this case. The solution shows that on an average 208 people have been deployed. Interestingly, despite the lower requirement for winter, the strength was maintained, as it was better to pay idling costs than retrenching them and redeploying at higher cost on the next quarter. The total cost in this case is 38,800. Interestingly, if we drop the headcount to 170 in winter, the cost actually goes up to 40,040. There is obviously no hard and fast rule. Depending on the costs involved, the final decision on the number of people to be deployed can be arrived at. In today's assignment, we have a similar problem with a small twist. The hiring cost is equal to 20,000 times the square of the number of people hired. So essentially, hiring is very expensive beyond a small number. The approach is similar. We work out the base wages, idling cost, cost of new hiring, as well as retrenchment. Our target is to minimize the overall cost. The solution in this case throws up some interesting insights. The maximum number of new people hired for a quarter was 3. The idling costs are significant, but retrenchment costs were low. So again, we have a slightly different strategy, but one that works for the particular set of conditions. Hope you found this useful. Look forward to staying connected. Do subscribe to our channel and stay updated.